Earth's interior. In the past decade, there has been a lot of videos showing lava flowing out of Mount Kilauea on the island of Hawaii. As that lava flows out and cools, it hardens into rock. And what you are seeing is an island being built. And that island is just evidence that Earth's surface is constantly changing. And throughout our planet's history, its surface has not only been built up into an island, but it's also been pushed down, it's been bent, it's been broken and lifted up again. Because of this, Earth looks much different today than when it did millions of years ago. However, scientists are still trying to piece together the answer to what's inside the Earth. Because the Earth's interior is over 6,000 kilometers to the center, and never mind that the extreme conditions would not even be survivable, geologists have had to use two main types of evidence to learn about Earth's interior: direct evidence from rock samples and indirect evidence from seismic waves. Now, scientists have tried to drill deep into the Earth, and as far as they can go, they try to bring up samples of rocks from these samples. And from these samples, geologists can make inferences about different conditions deep inside the Earth. But besides drilling, geologists also use seismic waves to study Earth's interior. If you were to walk over to the wall right now and knock across the wall, you would notice a different sound when you hit a wooden beam versus the hollow part of the wall. This is generally what geologists do when they record seismic waves and study how they travel through the Earth. Using the data from the seismic waves, geologists have learned that Earth's interior is made up of several layers. With Earth's interior being made up of these several layers, each layer surrounds the layers beneath it, much like the layers of an onion. The three main layers of the Earth are the crust, the mantle, and the core. These layers vary greatly in size, composition, temperature, and pressure. So let's take a journey to the center of the Earth. To begin our journey, well, you're already standing on Earth's crust. The crust is a layer of rock that forms Earth's, let's say, its outer skin. It's a layer of solid rock that includes both dry land and ocean floor. The crust also includes the smallest rock to the largest mountain range, along with the soil and water that cover Earth's surface. When you relate the crust to the rest of the Earth's layer, Earth's crust is very similar to that paper-thin skin of an onion. It's thickest where the highest mountain is and thinnest at the ocean floor. The crust is about 5 to 40 kilometers thick, with continental crust consisting mainly of rocks such as granite, and oceanic crust consisting mostly of rocks called basalt. As we start digging deeper towards the center of the Earth, we remove the crust and we go into the next solid material of the mantle. Earth's mantle is made up of rock that is very hot but solid. Scientists have divided the mantle into layers based on the physical characteristics of those layers. The three layers put together are nearly 3,000 kilometers thick. The uppermost part of the mantle, along with the crust, together form a rigid layer called the lithosphere and is about 100 kilometers thick. Right below the lithosphere is a hotter layer because of the increased pressure called the asthenosphere. It's not as rigid as the lithosphere and has the consistency of plastic that has maybe been set out in the sun too long. It's somewhat soft, but it can also bend, and although it's softer compared to the lithosphere, it is still solid. The lower mantle is solid and extends all the way to Earth's core. Now, if you thought you were hot in the mantle on our journey, wait until you reach the core. The core is made mostly of metals, iron and nickel, and consists of two parts: the liquid outer core and the solid inner core. The outer core is a layer of molten metal that surrounds the inner core. Scientists think that movements in the liquid's outer core create Earth's magnetic field. And because Earth has a magnetic field, the planet acts like a giant bar magnet. The inner core is a dense ball of solid metal. Extreme pressure squeezes the atoms of iron and nickel so much that they can't spread out. Thus, this is what makes the solid center. Okay, it's time to show what you know.